Okay, so I'm here to speak about how to build a good technology, not just for solving just problems that happen that or that you incur at this moment, but for building something solid for tomorrow. So how do you do that? You do that by picking a good architecture. One size never fits everyone, so you have to pick what suits your application and the product you're building. I'm here to speak about a quick refresher on some basic patterns. Because we have all sorts of talent in our audience, I want to give a refresher on different patterns we have, and then I have a small quiz towards the end, and then we would do some Q&A. Okay, so I've talked about different patterns, some real world examples, and then we can discuss back and forth. So I am Sireesha. I have over 17 years of experience in software engineering. I started by being a basic junior developer and worked my way up to be a software architect and currently the CTO for an advertising company called AdMedia. So if you've ever clicked on a Macy's or a Kohl's or a State Farm or any other big retail ad on different websites, thank you so much for giving me your money. And I'm so grateful to be working in ad tech. It's a very exciting industry, and I'm very happy to chat more about it outside of this presentation. Let me talk about why we need to discuss this subject at all. It's a Startup CTO Summit. I can talk about what it takes to become a CTO, or how to keep your team healthy and what a day-to-day life of CTO can be. But I chose this topic because I have a story. Are you ready? So there was this one beautiful Christmas holidays time in one of the past years. We are all wrapping to chill and take a break, stop all the releases, pause everything. It's that time of the year, right? It's the season. So it was a time where the company slowed down, and everything was going to pause and take a break. I had this extra hot latte in my hand. I walked into office. Where I live, it doesn't really snow, but it was still beautiful outside. We still had a little bit of fall colors, nice breeze, and it was just awesome holiday spirit. So I walk into the office and I saw some of our big enterprise customers and clients started sending complaints that some of their ad traffic was being compromised. It's dropping, it's not being served, and my heart just sank. I was feeling warm in my sweater, holding my coffee and settling down in my chair. But suddenly, my extra hot latte felt so cold. As I kept sipping it, I stopped it. Everything outside that looked cold looked like a hot summer day. I was sweating. I didn't know where things went wrong because all the unit tests checked out, all the production code checked out, everything looks fine when we test. What's going on out of nowhere? So eventually, good news being we figured out the issue. It was one of the big pictures we forgot to consider in the architecture decision that we were making. Things were a little bit slowed down as it was scaling. When we had our own search engine, we have our own advertising search engine that does a real time bidding to show ads. So it was slowing down as the number of queries and the complicated phrases and terms kept coming in to get ads back. So now, in my world, in ad tech world, every minute or every second we make or lose money. It's that important, and it's the holiday season. People are shopping online, right? Clicking on the ads. So it was a good news being we were able to fix it very quickly over a time period of a weekend. I don't think anybody in my team would ever forget that weekend. It was both exciting, satisfying, and also a good lesson. For a second, we all thought we failed, but there is no such thing as a failure, right? In life, you learn from this experience and apply. And that is when I figured it's very important. It's one thing that when you become a CTO, you understand, you go through different problem solving in technology. No architecture pattern is one solution to all problems. Not all the sexiest tools out there in the market are for you. Sometimes whatever is with you in house, you just have to tune it and make it work, right? So having said that, let's move on. I want to talk about a few architecture patterns. So this is very very old but still going strong. It's called a layered architecture pattern. It's, as the name suggests, and as delicious as the cake that you see on the screen. It has different layers, as you can see: DB layer, persistent business, presentation, blah, blah, blah. The best example is perhaps the most widely used email client, Gmail. So Gmail is still using a layered architecture and going strong. I can't think of my life without a Gmail right now. So we all use it every day. Some people think some patterns are outdated. Not at all. I'm here to burst those kind of myths. So layered architecture. Why do they use this? It's because it's very easy to maintain. Like Gmail, they have one layer to interact with users, another layer to render emails in different languages depending on international language setting. One layer that takes care of scheduling emails if they set to be sent differently, another layer to undo emails within a time frame. I can notice that you can undo your sent email within a few seconds, right? All those things. So it's worth mentioning that it's easy to maintain, obviously. We know as a proof that Gmail is a good application. It's pretty flexible. You can keep on adding layers, and they all cross communicate with each other. And it's a very perfect example to explain this. Then let's move on to the next one, most popular, right? Microservices architecture. It's nothing but it looks like a food court. So you've ever, I'm sure all of you must have been to a mall or a food court open, where you have all this variety of restaurants that you can go and pick and choose what you want to. So they can all independently grow. That is the biggest advantage. They can independently scale and independently offer different varieties. All you have to do is hook to that service and grab the information that you need, right? And they're all very independently maintained, like similar to in our technology, independently developed, deployed, scaled. You can have you can have five McDonald's in the same food court, if you will. And then it's also fault isolation. If there's ice cream machine broken in a McDonald's in one of them, perhaps the other one can have it, or there's a competitor like a gelato service next to it that you can go to and have yourself your treat. So this is the next variety. And we have a lot of examples in the real world. Uber, right? Uber must is using microservices architecture. It's a very well known. So they have independently launched like Uber Eats, Uber Drive, cab services, and they have also acquired Postmates in 2021. So that is a different service that you can hook and integrate with for authentication with the same login and use that service, so on and so forth. And then you have another, and my personal favorite, event driven architecture. So real time experience that you get on your mobile device, all these applications that you interact with, Uber or streaming services, all these things, these are made possible because of event driven architecture. Let me explain a little bit, because this is my favorite pattern. I want to spend an extra and give time and show some love to this. You have, basically, it is somewhat like very much like, uh, supposing I have a YouTube channel, and you are viewers, and you want to you subscribe to my channel to consume my content. Pretty much that's it. I have produced content. You are the consumer and you subscribe to my channel or my to be notified when I publish YouTube videos so you can watch them. So same thing, it is very similar to how you can when I publish content, you can imagine it would go into some kind of a queue that and then you as a subscriber, because you subscribe to my system, to my YouTube channel, you get a notification that there is a new video that released last night. Hey, do you want to see it? So it is very similar to a payload. You can assume like your baggage would be on the carousel in the airport, right? Like how they throw all the baggage for you to go and pick up. So assuming that you pick up your own baggage or not somebody else's, um, and the baggage is always waiting for you to get picked up, right? So the payload is very similar to that concept in this architecture. So many examples of event driven architecture. Uber, again, you can use your desktop and mobile phone and tablet to see where the driver is, how far they are away, or you can share that information with somebody you trust. When you get in a ride, they would know your whereabouts, that you are still halfway to your destination, whatnot. So it's loosely coupled, right? It's very easy. You have several producers and several consumers, they're all loosely coupled. Producers keep throwing information in an event broker, and the broker has all these topics or channels like YouTube channel, like subscribing to it. Consumers go ahead and subscribe to the topic to consume that information. So it's not tightly coupled like a layered architecture and other patterns, very loosely coupled, and you can have several event consumers. Another very good example of this is an e-commerce website. So if you go to any like Macy's.com, let me take example of the client I work, the advertiser we work with. So Macy's.com, you can do online shopping, right? You pick a dress or shoe and all that. You put it in the checkout and you go check out and pay the money. You check it out. Then there can be several consumers to be notified of this event, and then like logistics, like shipping, like email services. So somebody made a purchase of this dress, then logistics will get an event information. This dress belonging to this category, it has reduced by amount of one, so it will update its inventory. And perhaps email will go out, right? That is another consumer. It gets a notification that, hey, this customer with this email address has made a purchase, and it sends an email out saying thank you for your purchase, here is your order, here is where you can track blah blah blah. You get all those emails, so on and so forth. So you can see how it is extensible, right? You can add as many consumers as you can to scale it, like logistics, email, inventory, so on and so forth. Let's move on. And finally, something that none of the previous architecture patterns cannot work is cache and load balancing. Every system needs a caching and load balancing as you scale. It's pretty much like a snack, similar to how we keep snacking all day and pick your own snack kind of a thing. You have so many caching mechanisms with different eviction policies, or you can even design your one top level. You can try to evict something that is oldest in the system or least used or random, whatever. You can define your own caching, and then you have load balancing. Without load balancing is like a good sports team, right? So it will fully the idea of using a load balancer is to make sure your traffic and your network and your product will never collapse, and it is nicely load balanced across different buckets when traffic navigates from different locations. A very easy example to this is geographical. So in geographical traffic, right, like google.com, you have users from all over the world visiting the website. So you need to make sure that it is properly load balanced. Somebody sitting in Asia will not hit a data center for Google in United States. Google has a data center in several Asian locations, so it picks the nearest one, so the latency is reduced. So this is some of the patterns I explained about. I want to know from you in chat to guess what these kind of blueprints are used. Like Netflix. We stream videos from Netflix. Can you guess what kind of blueprint it's probably using? Is it microservices, event driven, etc. Same thing with Amazon and then Twitter. I want to see your comments so I can help you by answering the questions. So what do you think Netflix might be using? Murat, can you guess?
Uh, Probably layered architecture.
It's probably a combination. I think
Of
once.
It's always a combination with large companies like that, you know.
Yeah, of course. So Netflix. One second. For some reason, I'm blanking out myself. Da, da, da. Right. Netflix is using microservices,
Yes, microservices is, yeah.
and Twitter is event driven, obviously. Right.
Yes.
Somebody fires a tweet, it needs to show if it is public. And Amazon is load balancing because they have millions of requests coming through all the time. So,
Um, and in the large companies, and somebody just commented as well, Amazon being microservices as well. It's obviously there are going to be different parts of the area is going to use different patterns in there. So, what do you think? Like, how is the CTO is going to balance between different patterns and practices out there?
yeah, so this is where I want to get in, and I think this should also help answer my response right now to Nick. You also asked, it's kind of together. I want to club it. Do you think CTO needs to hear what a layered architecture is? I understand you would be surprised. A lot of CTOs out there, a lot of people in charge of engineering may not 100% be hands on,
Agree.
so they might follow what's going on in the news and pick that without proper evaluation. And I think that's a mistake. And that is exactly why I went through these details in the presentation to give some backdrop, to give some insights into different patterns. Sometimes, like I said, microservices is not for every organization. It sometimes you can get job done with layered architecture. So it's very important for people in leadership positions, VPs, managers, to understand these patterns to see what fits their bill. Not everybody might need a event driven architecture. These are all expensive architecture the tools that comprise to make these things work are very expensive. Do you really need to spend all the money on all the tools too, just because everybody else might be using it? No, I disagree with that approach. Case in point is there was an instance in house where we had to do a full text search against a database. And immediately some of the folks like they want to use Elasticsearch, this and that, but it might work for e-commerce website kind of applications, but we were looking for something that is not e-commerce. We were looking for quickly responding with some minimalistic payload text ads very quickly within some latency limits we have. So that's how the real-time bidding works in ad tech. When you see a website, when the website loads, they're auctioning the real estate spots on the side. So we have to respond very quickly in micro milliseconds And in which case, an elastic, we can't afford the delay that an elastic search might even take. So this is why I think people need to be aware of all the architecture patterns.
No, totally agree. It's one of the things I think as a CTO, quite a lot of things that you might be very familiar with this different patterns and practices, but quite a lot of the CTOs are overwhelmed with the day-to-day stuff. We first mentioned earlier is how to survive and keep it up. It's great to remind even the basic patterns and practices that's been forgotten on the day-to-day stuff, unfortunately.
Yes, I also think that CTOs should get their hands dirty, and
Definitely.
that is, I think, the ultimate way to know a system in and out, because when push comes to shove, they should be able to roll up their sleeves and get to work. I
Yeah.
think a reason somebody should would become a CTO is not because they just are able to order people around, but also to be able to do something hands on that the other team leaders, other company leaders may not be able to do.
Yeah.
So it
So I have a quick question. So obviously you're big, and one of the things that we are looking at this summit as well. How do you leverage other people? Like, who are the people that you choose to leverage
uh, leverage for what?
for
For
your day-to-day job?
Yes. So when I hire people, I don't ask them to solve a binary search tree. I don't do that. That is useless for me. Okay. I hire people who have problem solving skill sets. They may not be the best coders. That's fine. I look for people who have that fire in the belly to solve a problem, because that's the only way that's the only way people can think, I feel, on their feet, and fit right in to make the team stronger. And
Okay,
that is where we are more selective in, and that is all. I very much like that kind of style and approach.
that's great.
Sorry.
So, what type of resources do you use to keep up with all the patterns and practices that's coming up in the industry?
I keep looking at system designs of various products. So, for example, right now I'm trying to understand the system design and architecture of OpenAI. I may not be building an OpenAI myself, but it's important to understand their way of approaching the problem. The
Yes.
same, in the same, say there are many AI tools out there. They all must be approaching differently. So it's
Mhm.
important to understand how they are solving the same problem differently. So I subscribe to some system design educational videos. There's so many people out there, so I keep track. I try to keep up to the trends that way. I also
Yeah,
actively have my team members listen to them a lot. I give them a chance to solve the problem before I finally decide what solution we might take.
thank you very much, Sireesha, and it was very useful to be able to overview of patterns and practices and be able to see how people are actually utilizing it.
Yes,
And from the first-hand experience, I love the idea that you said your hands needs to be dirty, and I totally agree with you. And thank you very much for your talk, and looking forward to see you in the panel discussion.
thank you all so much. You're all awesome that you listened to me today. Thank you.
Thank you.